All right, thank you so much for joining us today. And in this video, we are going to talk about integration by part. Let's start. So the first one here is we want to compare this to the left here, right? So the idea is that what will be my u and what will be my divine? Very important, right? Because when I compare this to this, so let me write them here. Integration 3x e to the power minus 2x dx with integration u divine. Now, choosing my divine and choosing my u is very important, which will lead me to something which is very nice. So what am I going to do? Anytime I'm doing integration by part and it's in terms of an exponential function, then it's best for me to choose my divine first. So what I'm going to do is, since this is in terms of exponential function, I will choose my divine to be equal to the exponential function dx. So this one will be e to the power minus 2x dx always. This is better. This is good for you to do that, because anytime I have an exponential function, I pick the exponential function with dx. Yes. So now that I've taken out the exponential function and the x, anything left is for u. So what will be u? U is going to be 3x, because if divine is equal to this one here, then it means that du should be equal to what is here, what is left, right? And then the integration goes with the integration. So it means that here my u is equal to 3x. Now, we're able to compare the left to the left. The next thing is this integration here should be equal to the right also here. But on the right, we need u, which we have. We need vein, which we don't have. And then we need also du, which we don't have. So this will help us to find du, and then this one too will help us to find vein. Right. So now let's go through. So let's differentiate this with respect to x. This is going to give us 3. And guess what? Our du will be equal to 3 dx. So now we know u, we know du, which is very okay because we have u here, we have du here. The only thing left is vein. So we can get the vein from this. So what can we do? We can integrate both sides, because when you see the vein, it means that the function has been what? Differentiated. So this is what you are going to do. And then differentiation takes away the integration. So we are going to be left with vein, which is equal to, now, I think I should put my x somewhere here, 2x dx. Now, how do we differentiate, how do we take the entire derivative of an exponential function? Is maintain the exponential function divided by the derivative of the power here, which is negative 2x. So when I differentiate negative 2x, I get a negative 2. So I'm going to divide it by negative 2. I'm not adding constant to it because I'm not done yet. So now when you look at the right hand side, we can see that we have u, we have vein, we have du. So now we can now equate this integral to the right hand side. So what will be our integration? 3x e to the power minus 2x dx is equal to, it's equal to what is here, but we know that u is equal to this. So I'm going to have 3x times vein is here. So I'm going to have e to the power minus 2x divided by minus 2 minus, I have my minus here, the integration vein, I have my vein here. So I'm going to have e to the power minus 2x divided by minus 2, and then du is here, so I multiply it by du. So this is kind of interesting. So what we need to do is we just need to simplify that, and we are done. So this is going to give us negative 3 over 2x e to the power minus 2x minus, So I have minus here, I have minus here. I can write it as plus, and then I can factor there. Since I have divided by, it means that I have 1 over 2 here, and I have 3 also here. So I can write this one as 3 over 2 integration minus 2x dx. This one's supposed to be the x because du is equal to that. So now let's finish that one up. So what can we do? This is going to be minus 3 over 2x e to the power minus 2x plus 3 over 2 times. Now when I integrate this, what am I going to get? Exponential function. Maintain the function divided by the derivative of the top. And then since this one is indefinite, I add plus c. Good. So let's do the simplification and see what we are going to get for the final step. So this is going to be minus 3 over 2x e to the power minus 2x minus 3 over 4 e to the power minus 2x plus c. So this will be the final answer for the integration by parts. Good. This was the final result for the integration by part. Good. So we chose our u, we chose our divine, and then we went through the process. So now let me just shift some of the solutions up so that we can look at the next question. Okay. So now let's look at the B. The B is interesting because for the B, we are going to actually do integration by part twice because of something. So let's go and find out that thing. So now here, as I told you, looking at the formula, so always when you want to do integration by part, the first thing that you need to do is to write down the formula, right? So let's do that. So u divin is equal to u vin minus vin du. So it means that we need u, we need divin. So as I said, always if the function is in terms of an exponential function, pick the exponential function with what? Dx. So the exponential function is this. I'll pick that one with dx. So I'm going to have e to the power 3x dx. Only exponential function. You will get a function where it does not involve exponential function, and we will know how to go about that. So when I take this one out, what will be left? When I take the exponential function and the x out, what will be left? It will be left with 5x squared. So looking at the formula, I need u, which is here. I need vin, which I can get it from here, and I need du. So the same process. So I'll move fast. So this is going to be du over dx, which is equal to 10x, right? So what will be du? Du will be equal to 10x dx, right? And then I need vin. I can get vin here. So it's the same process that you are going to go through. So I integrate this, I integrate that, and my vin will be equal to e to the power 3x, divide it by the derivative of the top, which is 3x, which is going to give us 3. So I'm done. So what I need to do is now my integration, which is this here, my integration, which is this here, is now what I'm going to write. So this is going to be integration 5x squared e to the power 3x dx to be equal to u times vin. So u times vin, I'm going to have 5x squared times e to the power 3x divided by 3 minus, what is vin? Vin is here. So e to the power 3x divided by 3 times, what is du? Du is this here, right? So I'm going to have times 10x dx. Now this is going to give us 5 over 3x squared e to the power 3x minus, now I have 1 over 3 here and I have 10 here. So I'm going to have 10 divided by 3. And then I have this and this here. So I'm going to have x e3x dx. So look at this one here. We saw from here that after the integration by part, when we did simplification, we didn't have any x here. the function left here was just 1. So we were able to just integrate this and add this, right? But remember, whenever we are talking about integration by part, then it means that we need to have 2 functions. So after the first integration by part, we have gotten another function which is also product again, so x and this. So it means that we need to do another integration by part. So that's the reason why I'm saying that this one we need to do it 2 times. So what I'm going to do is I'm going to pick the one I need to do integration by part again and try to do it. So I'll divide my board into 2. So I will divide my board into 2 like this. So what I need to do is now I need to pick this, only this, and do integration by part again and come and do substitution. So u x integration x 3x dx. So as I said, anytime I have an exponential function, this will be my div. So my div will be equal to the same thing, 3 e to the power 3x dx, and my u will be equal to x, which is here. So now my du over dx will be equal to 1, and du will be equal to dx. And then this one, when I integrate both sides, as we did for the first one here, when we were finding for this one, where is it? When we were finding for this one, it's the same thing here. So I'm going to have fin to be equal to e to the power 3x divided by 3. So you see, what I'm doing right now is just only this. So now this one will be equal to integration x e to the power 3x dx will be equal to, now the same, I'm applying the same formula again. So u times vn, which will be x e to the power 3x divided by 3 minus integral of u times dx. So what is, sorry, vn times du. So this is vn. Du now is equal to dx. So I'm going to have e to the power 3x divided by 3 dx. Let me simplify this. X e to the power 3x divided by 3 minus, now when I integrate this, I can factor the 1 over 3 out. But when I integrate this, what am I going to get? I'm going to have e to the power 3x again divided by 3. So this is what I'm going to get. So on this part, I'm going to have this. So what I'm going to do is I'm going to replace this by what is here. So that is what is going to cost us when we need to do integration by part 2 times. So let me shift this one up small so that we can use the space. Good. So this is what we are going to do now. We are going to do substitution. So I'm going to have 5 over 3 x squared e to the power 3x minus 10 over 3. Now when I finish the 10 over 3 here, now this is equal to the whole of this. So I'll open my square bracket and I put x to the power 3x divided by 3 minus, now when I simplify this, I'm going to have minus 1 over 9 e to the power 3x, and then I'll add my c. I hope you've gotten what I just did. So after getting here, I saw that I need to do integration by part again. So I just need to pick only this, which is here, and do integration by part again. So now we see that this, which is here, is equal to this. And then I just came to plug it in here. And I add plus c. So if I want to do my final simplification, and then I can just write this one as 5 over 3x squared e to the power 3x minus, then I can multiply this by that, and I'm going to have 10 divided by 9 x e to the power 3x. Then I multiply this one by this. I'm going to have plus 10 27 e to the power 3x plus my constant c. So that's what I'm going to get with this integration by part here. So that is integration by part. Let's look at C. So let's look at C2, the same integration by part. So the first thing the first thing I need to do is write down my formula here, u vin minus vin du. Good. Then I need to choose my u, I need to choose my vin. So we said anytime the integration involve exponential function, then I need to pick my exponential function with the x. That should be my vin, right? And then any or the one which is left, now when I take this one out, the one which is left now becomes my u. So my u will be x plus 1. Then if I have u and the vin, I need to look for du. So this one is 1. So du is the same as the x. Then I need to look for vin from here. So you see that the process is also the same thing. But make sure you wait for question D and E because it involves a different function. So when I integrate e to the power x, I maintain the function, then I divide it by the derivative of the top, which is 1, and this is the same as that. So all I need to do is let's now fix in the integration. So integration from 0 to 1, x plus 1, e to the power x dx. Now this is equal to, so remember the first two that we did was indefinite. Now we are dealing with definite. So look at how we are going to do it. So the same thing, u vin minus vin du. So let's go. U is x plus 1, vin is e to the power x, then minus vin is e to the power x, and then du is dx, right? So what I'm going to do is, you see, I still have this one here. I've not used them. I will use them. So this is going to be x plus 1 e to the power x minus. Now I need to integrate this because now I don't have the product again. I have only one function. And when I do that, I'm going to have e to the power x, right? Because when I integrate e to the power x as we did here, we had the same thing as this. Now I put my 0 to 1. So the only difference between definite and then the indefinite is that when I finish my last simplification here, after I'm integrating this, I add plus c. But this one, because it is definite and I have my upper and lower limit, when I finish my light integration, I put this bar here and I put my limit on it 0 to 1. So guess what I'm going to do? I'm just going to plug them in. So plug 1 in. So when I do that, I'm going to have 1 plus 1 e to the power 1 minus e to the power 1 minus, I open the parentheses, then I plug in 0. So 0 plus 1 e to the power 0 minus e to the power 0. And we are going to have 2e minus e minus, this is going to be 1 minus 1, and this is going to be 2e minus e is going to give us e, and then 1 minus 1 is going to be 0. So the final result here should be e. Interesting. So that's what you are going to get for C. Now let's look at D. D is totally different from A, B, C, right? Because A was involving the exponential function, same for B and C. Now we see that this does not involve the exponential function. So what will be our du, what will be our divin, and what will be our vin? So let me write down the formula first. So u vin. So this is how you're supposed to do it. Any integration by part question that you are going to do, try and record the formula so that you won't forget. So now, what is my u? What is my vin? Now, anytime you are dealing with an integration which involves the natural log function, then your u should be the natural log function. We said if it is an exponential function, your divin should be always the exponential function, the x. When it involves the natural log function, always your u should involve the natural log function. So when I take the natural log function, what will be left? X squared dx. Don't forget, the vein should always go with a term and dx. Good. So this one is going to be x squared dx always whenever I'm dealing with natural log function. Okay, so let's go through the same process. I need du, so this is going to be, when I want to differentiate a natural log function, this is going to give us x divided by 1 divided by x, and du will be 1 over x dx. Let's try and find vein from here, and I'm going to have this one to be vein, which is equal to x to the power 3 divided by 3. Interesting. So now we can go through the integration now. X squared natural log of the x, and this one should be equal to the right hand side. So u times vein, u is here, vein is here. So I'm going to have ln of x times x to the power 3 divided by 3 minus integral of, now what is my vein now? This is my vein, right? So I'm going to have x to the power 3 divided by this times, what is my du here? So times 1 over x dx. Let's try and simplify. This is going to give us 1 over 3 x to the power 3 natural log of x minus, here I can factor the 1 over 3 out. So I'm going to have minus 1 over 3 out. And guess what? One of the x will cancel one of the x here. So this one will be left with x squared dx. So let's move to the final step. 1 over 3 x cubed ln x minus 1 over 3x. Now when I differentiate, when I take the entire derivative of x squared, I'm going to have x to the power 3 divided by 3 plus c. And then this one, I just simplify and then I'm just there. So let me move this one up small and let's do the simplification. Good. So what will be the final simplification? This is going to be 1 over 3 x to the power 3 natural log of x minus 1 over 9 x to the power 3 plus c. So remember, whenever you have a natural log functions like this, your u is equal to the ln x. It should be equal to the natural log function. Good. Let's look at the last question here. So the last question here too is like the one with the natural log but having limit. That is the definite. This one is the indefinite, right? The one that we did here is the indefinite. So let's look at what we can do. Same thing. Write down the formula. And then vein du. Now I choose my u, I choose my vein. Now we know what's supposed to be u. U should be the natural log function here. So 3x. And then if I pick this one out, everything left is my du, sorry, the vein, so x dx. Good. So from u, I can get du. So when I differentiate ln of 3x, I'm going to have 1 over what is inside the parenthesis times the derivative of what is inside the parenthesis will be 3. Good. Then let's look at integrating the vein x dx. So this one will be vein, and when I integrate x, I get 1/2 x squared. I think I should have simplified this. So this one should be du over dx, which is equal to 1 over x, and then du is equal to 1 over x dx. So we have all the ingredients. So now we can start integration from 1 to e, x e to the power not e ln 3x dx is equal to, what is the integration by part formula? U times vein. So this is u times vein. So I'm going to have u times vein minus integration of then du. So then du. So I'm going to have 1 over 2x squared times 1 over x dx. Simplify, and we have 1 over 2x x squared ln of 3x minus, I can factor the 1 over 2 out. So I have 1 over 2 out. And 1 of the x will cancel 1 of the x here. What will be left with x dx. Let's go. This is 1 over 2 x squared natural log of 3x minus 1 over 2. When I integrate x, I'm going to have 1 over 2x squared. But remember, this is definite. So I'm going to have it to be from 1 to e. So now when I simplify it, 2x squared natural log of 3x minus 1 over 4 x squared from 1 to e. Then the last thing that I need to do is plug in this inside the whole function minus this inside the whole function. So let's see how the simplification will be. 1 over 2e squared natural log of 3e minus 1 over 4 e squared minus, then I plug in 1. So you see that when I did the minus, I bring my parentheses because the function here is not just one quantity, it's two of them. So I'm going to have 1 over 2, 1 squared, ln of 3 times 1 minus 1 over 4. So let me shift this once more. Minus 1 over 4, 1 squared. So what are we getting? 1 over 2e squared, ln of 3e minus 1 over 4e squared minus 1 over 2 then 3 minus 1 over 4, and we are getting 1 over 2 e squared ln of e minus 1 over 4 e squared minus 1 over 2 then 3 plus 1 over 4. So this is what you are going to get at the end of the day. So this is integration by part. This is how we do it. We have different functions and how we do integration by part. So the idea is that it's always a best way to figure out what is the way. If I see this integration and I'm going by integration by part, how do I approach it? So now we know that when it involves an exponential function, the best way is to choose your div to be equal to the exponential function dx. And when it involves the natural log function, the best way is to choose u to be equal to the natural log function. We have different functions and how you choose your div and you choose your u. All right, see you in the next video.